Hello, good afternoon to all of you. I hope all of you are doing well, and please do stay safe. So, in today's class, what we do is we try to go through the last model that we have, that is called a spiral life cycle development model. Now, spiral life cycle development model is one of the models that has evolved from all the other models that we've studied till now. So, it encompasses in it the best of the attributes of all the other models that we discussed till now, that which are waterfall model, evolutionary model, prototyping model, VNV model, rapid application development model, component assembly model, and so on and so forth. So spiral life cycle development model has in it the best of the attributes of all the other models that we have discussed. Now, a spiral model, in addition to the attributes of the other model, has in it an explicit phase for risk management that tries to efficiently manage risks, and we have not seen such kind of attribute in the other models that we have discussed till now. Now, a spiral model has in it four identifiable phases. The four identifiable phases that today's spiral model are determine objectives, alternatives, and constraints. Then evaluate alternatives and identify and resolve risks. The third phase that we have is develop the next level of the product. And the fourth phase that we have is plan next phase. I'll again repeat it. Spiral model basically has four identifiable phases. The first phase is to determine objective, alternatives, and constraints. The second phase that you have is evaluate alternatives, identify and resolve risk. The third phase that you have is develop the next level of the product. And the fourth phase that you have is plan next phase. Now, in across these four identifiable phases, a set of activities are performed. Now, the first phase that we have, as it is given here, determine objectives, alternatives, and constraints. What we tend to do is we tend to identify all the functional and non-functional objectives that are required from the system. So the first quadrant identifies the objective of the product and the alternative solutions possible. So here, what we tend to do is we tend to identify all possible functional and non-functional requirements. And once the functional and non-functional requirements are properly drawn, so a functional requirement includes various functionalities that are to be attained for providing solution. Non-functional requirement includes like performance issues, quality assurance, right, and so on and so forth. So once the set of objectives are properly drawn, that includes functional and non-functional requirements, then the alternatives for each and every objectives are fixed upon. So alternatives basically refers to how we are going to attain the objective. So for each of the identified objective, a set of alternatives are defined. So alternatives can be either you may develop the functionality by your own self, or either you may buy it from someone else, or either you may reuse it, or you may subcontract it to someone else, right? Okay. So once the alternatives for each and every identified objectives are put in place, then what we tend to do is we tend to also associate or determine constraints that are associated with the objectives. So constraints basically issues like cost, schedule, time, environmental implications, and so on and so forth. So with each and every associated alternative, what we tend to do is we tend to draw in various associated constraints, because you know that constraints govern the development of the alternatives. Now, once the constraints have been properly drawn for each and every alternative pertaining to the various objectives, then what we need to do is we need to also look forward in terms of risk associated with the various aspects like lack of experience, new technology, schedule, poor processing, and risk associated document, and so on and so forth. So in the first phase of spiral model, that is identify objectives, alternatives, and constraints, we tend to identify objectives. With each and every identified objectives, we tend to identify a set of alternatives. With each and every set of alternatives, we try to associate constraints. Now, once the first phase is over, the next phase is initiated. The next phase of the life cycle model is evaluate alternatives and identify and resolve risks. Okay, so it's very much important because each and every alternative has to be evaluated in terms of its productivity, whether it is suitable for a particular objective or not, right? And we need to identify and resolve risk. So there might be different types of risks that may be associated with the alternatives. So namely, risks are, to define a risk, risk is an anticipated event that may lead to a failure. And any anticipated event that may lead to failure is called as risk. So risk can be categorized into three different categories, like project risk, you have technical risk, and you have a business risk. So project risk concerns issues like schedule, cost, and time, resources, and so on and so forth. So any risk that is associated with these very attributes, it's called as project risk. Likewise, technical risk basically concerns issues related to the technical know-how, whether you have the knowledge for developing the software application or not, whether you have adequate technical support in terms of third-party assistance for developing the system or not. So this falls into the category of technical risk. For the business risk concerns issues like competition from the market. So, an example, if you have a rival who's developing a product that looks like your product and is much more efficient than that of yours, with a reduced amount of cost. Now that is a business risk, because it may so happen that you may build up a product and you may not have a client for that. So that falls into the category of business risk. So any risk that may be associated with the alternatives can be categorized into these two categories. It may be categorized into project risk, it may be categorized into technical risk, or it may be categorized into business risk. Now, once the risk has been categorized into identifiable categories, then what we need to do is we need to assess the risk or analyze the risk or determine the priority of the risk, because higher the damage causing potential of the risk, higher will be the priority of the risk, and higher will be the cost investment required for managing that particular risk. So the next phase that we have after risk categorization is risk analysis, or it's called as risk analysis or risk prioritization, where we try to determine the damage causing potential of the risk and the associated priority. So once the damage causing potential and the associated priority has been identified for each and every risk associated with the alternatives, then what we tend to do is we tend to devise effective containment plan. So how you're going to manage that particular risk. So if a risk is a very low priority risk, then what you can do is you can ignore that particular risk or avoid that particular risk. If a risk has a very nominal influence, then what we can do is we can accept that particular risk. If a risk has a very high priority or a very high damage causing potential, then what we need to do is we need to reduce the influence of the risk. So reduction can be done by one own self, or it can be transferred to some other person for managing that particular risk. So these are the various risk management steps that are involved in managing risk. So once the alternatives have been evaluated, the associated risks have been identified and resolved, then what we do is we initiate the next level of the product, or develop the next level of the product. Because once the objectives are identified, the associated risks are resolved, then what we can do is we can now develop the objectives, right? So in this particular phase, what we tend to do is we tend to develop and verify the next level of the product. So here, what we do is we execute phases like design, review of design, development of code, inspection of code, testing, and packaging. Here, in order to save time, Spiral model heavily relies on the use of a linear model like rapid application development And for verification, it relies on verification and validation model, that is V-shaped model. So as I've already said, spider model tries to inculcate the best of the attributes of all the other models. Now, once the next level of the product has been developed and verified, so now what we need to do is we need to plan next phase. The fourth phase is to plan next phase. So, what is the next phase that we are going to initiate in the development life cycle? So, it can be a phase that concerns development of the next level of the product, or so, for an example, it may be configuration management, a phase for configuration management, or phase for quality management, a phase for installation, or phase for designing test plan, and so on and so forth. So this is the way how a spiral model basically progresses. Now, let us go into the spiral model in little bit detail and try to analyze the pictorial representation. So here what we have is we have four identifiable phases. The first phase is determine objectives, alternatives, and constraints. So this we have already discussed. In this particular phase, all the functionality, functional and non-functional objectives are drawn, and the associated alternatives are identified along with the associated constraints. Now, once the objectives have been identified and the alternate objectives alternatives and constraints have been identified, then what we need to do is we need to evaluate each of these alternatives and identify and resolve risks. So now, in order to identify and resolve risks while evaluating alternatives, prototype assistance of prototyping model is taken. So here, prototypes are being built, risks are being identified, and risks are being resolved. So, as I've said, spiral model also relies on prototyping model. So, this is the reliance of spiral model on prototyping model. So, it is used for efficient risk analysis and risk management. Now, once the risks have been identified and it has been resolved, with associated with each and every alternative of a particular objective, then what we need to do is we need to develop and verify the next level of the product. So in order to develop and verify the next level of the product, the first and the foremost thing that one has to do is to understand the concept of operation. So how the system actually operates and deliver results. So now, in order to understand the concept of operation, what you can do is you can have an assistance of emulation process, abiding by certain model and setting certain benchmark at place. So once the concept of operation has been properly drawn, then what we can do is we can move on with software requirement specification. Then we can move on with requirement validation. Now, as I've also said, my spiral model relies on verification and validation model. You see, so after every step, what you have is you have a verification and validation phase. So software requirements are specified, requirements are validated, then software product design is formulated, then design is validated and verified, and then what we have is we have detailed design, we have coding, we have unit testing, we have integration testing, we have acceptance testing, and eventually we have implementation of the software to the client's environment. So this is the way how the progression takes place in spiral model. Now, one thing what I want you to remember is that in case of spiral model, the cost of the overall development is the function of the radius, because as and when the number of spiral increases, the cost of the software development lifecycle also increases. So more the radius of the spiral, of the outermost spiral, more will be the cost. Now that is just a qualitative notion of representing the cost. Now, these are the various attributes of spiral model. So let's go through a few of the advantages of spiral model. Now, one of the foremost advantage of spiral model is, as I've already said, it has the goodness features of all the other life cycle models that you've discussed in now, right from waterfall model to prototyping model to verification validation model to evolutionary model to rapid application development and then the component assembly model and many more. Now, so it has in it the goodness criteria of all the other models. Now, this particular model also incorporates software quality objectives in software development, because in this particular model, what we have is we have a continuous verification and validation done of all the life cycle phases and of all the intermediate products. So quality is assured. And the third important advantage of this particular model is that this particular model has an explicit phase dedicated for risk analysis and containment. So here in this particular model. So efficient risk analysis and validation steps eliminates error very early in the development life cycle, because before the development of the actual product or the next level of the product, risk analysis is done. Now the model also makes use of techniques such as a reuse, prototyping, and component assembly. Right? Okay. Now it all this particular model also works in situation where at the start what you have is you have a very imperfect design. So what you can do is over a period of time, what you can do is you can refine the design of the overall software system. Now, in this case, there is increased participation of the customer during the software lifecycle process, so which definitely ensures correctness, resulting in a very high quality. Now it becomes very easy it becomes very easy in situation where what you can do is you can easily monitor and control the various quality, correctness, cost, schedule, and staffing in spiral model. Now, these are the few notable advantages that a spiral model has in it. Now, let us identify a few of the disadvantages this particular model has. Now, this model is definitely not suitable for a project of relatively smaller size, as it has very many set of identifiable phases which are to be executed. Now, here in this particular model, what we require expertise for risk management and efficient project management as well. Because here there is explicit phase for risk management, and since the number of phases are very large, what we also need an excellent project management skill. At point in time, people may find this particular model difficult to use because of the complex orientation of the various phases that it has. So these are the few important lags of a spiral model. In situation, spiral model may be quite difficult to use, but it has the best of the properties of all the other models that we discussed till now. So this ends the second chapter of software engineering. So in the next class, what we'll do is we'll start with the third chapter of software engineering, that is requirement analysis and specification. So thank you very much. All of you do stay safe.